Hello. Alright, so this is just me going over lab 13 for those who need extra help. So first thing I want to answer is where are the metals, the majority of metals located? And you should notice that they're on the left side, right? The ones are in red, so hopefully you heard that, left side. And the majority of non-metals is already, oh, I already wrote the answer for it. All right, well, it's on the right side, right? Spoiler alert. So the ones in blue are metals, hopefully you knew that already. What subatomic particles present bonding, right? So remember, protons never change, neutrons affect the mass, and then if you look at your notes, there's a transfer of electrons, right? So electrons are transferred in ionic, and they're shared in covalent. And then valence electrons, if you recall back from unit 1, it's just electrons in last orbital. I don't know, you don't need to put that in your own words. I mean, how would you describe that? Electrons in last shell, electrons in last orbital. Either one is fine. All right, so now what you gotta do is click on this link and it should take you here. So let's double check it actually works still. And it does. So around this virtual lab, it says choose sodium, right? It's not, yeah, sodium's Na, not S. So choose sodium, which is natrium in Latin. And you click on it. It says, what type of element is it? The answers are right here. So what type of element is it? It's a metal. And you should notice, if you wrote down that the valence electrons are the last number, the, the valence electrons for sodium is 1. Why? Because the outer orbital is 1 electron. Can you see that I circled that? Hopefully you can. So sodium is 281, so it has 1 valence electron that participates in bonding. Okay. Then we have fluorine, so we choose fluorine. So fluorine is F, the most toxic, well, one of the most dangerous elements, arguably the most, and it's 2-7. So why does it have 7 dots? Because the valence electrons and the electrons in the last orbital, and for fluorine, it has 7 electrons in the last orbital. 9 total electrons, but 7 in the last one. That's a really scribbly too. Right? So answer the question on the screen. What type of bond is likely to form? So remember, this is a metal and non-metal. So if you go back to your notes, metal and non-metal is ionic, and 2 non-metals is covalent. Okay. I don't know why this cat likes to scream every time we do a video. But anyways, so what type of bond is likely to form? Do you answer that? No. So it's ionic. And now this is the part you need help with. So one thing you have to keep in mind is that compounds have to be balanced. So sodium is +1, right? See how it says +1? And fluorine is -1. Do those two numbers balance out to give you 0? And very good. 1 plus -1 is 0. So we need 1 sodium atom and 1 fluorine atom. That is already answered for you. I just wanted to explain that because you should understand that before we get into the difficult work. So this is watch the animation. These are structures that they actually ask you to draw in the regions. So sodium lost an electron. You notice that? So it lost that valence electron. So if you lose a negative number, you are now positive. So notice, let me clear this up. If you lose a negative number, you're positive. If you lose an electron, you're positive. If you gain an electron, which fluorine went from 7 to 8, now it's negative. And now sodium, since it lost an electron, sodium is not 281 anymore. Sodium is 28. Remember, they all want to be like noble gases. So sodium is like a noble gas. And now fluorine is not 27. After it gains a negative electron, it's also 28. So that is why it looks like neon, because it gained an electron. Describe the change. I just said that. So sodium loses 1 and fluorine gains 1. And if you don't want to memorize that, just look at the oxidation state. If you see +1, it's always losing one when it bonds. If you see -1, it always gains one electron when it bonds. Okay. Blah blah. What does a positive charge indicate? I just said that. You lose an electron when you're positive, and if you have a -1, you've gained one electron. And +1 and -1, the overall charge is neutral. All compounds are neutral. Okay, so all compounds are neutral. If it was not neutral, it'd be known as an ion, or if it has more than one element, polyatomic ion. Okay. What is the name of the and formula for the compound form? So it's right here. So the name is sodium fluoride. And the chemical formula is NaF. So that's another thing that you should keep in mind. So when they say like H2O is a chemical formula, NaF is a chemical formula, NaCl is a chemical formula. So chemical formula is NaF. Now hit the reset button. Okay. So now choose calcium, it says. You need more and more calcium as you get older. The majority of humans don't store calcium after 25 to 30. So if you don't want to be like Paul George and break your shin when you're playing basketball, get your calcium. Right? I really am afraid I'm going to hurt my shins. Anyways, so calcium is over here. So notice how calcium has 2 dots. Why does it have 2 dots? Oh, look at the electron configurations. 2, 8, 8, 2. The last number is 2. So it has 2 valence electrons, 2 dots. And now it says click on chlorine. Right, chlorine's right here. Chlorine has 7 dots. Why does chlorine have 7 dots? Probably because it has 7 valence electrons. And it does. 2-8-7. Right? That's 7 is the last number. And this part, this simulation is not really good for determining the chemical formula. So that's why I told you the answer. So calcium, oh, and first, is it ionic and or covalent? It's ionic because it's a metal. Metals are in blue, and non-metals are, I'm sorry, metals are in red. Metals are in red, non-metals are in blue. So if you have a metal and non-metal, metal, non-metal, that is ionic. Ionic compounds are always metal and non-metal. Then it says predict, but the answer is right here. So it's 1 calcium atom, 2 chlorine. And why would you need 2 chlorine atoms? You should be asking yourself. So why 2? So each chlorine, in the majority of cases, if you could read that, says -1. So the majority of cases, each chlorine wants 1 electron. And in 100% of cases, calcium wants to lose 2 electrons. So how do I balance out 2 and -1? I need double the amount of chlorine, and I only need 1 calcium. That's why you have 1 calcium and 2 chlorines. +2 and -2 equals 0, right? We watched animation. Why were there 2 total atoms need to create? Why were more than 2 total, right? So why are there more than 2 total? Because if you only had 1 calcium and 1 chlorine, that would not balance out. Right? 2 minus 1 is not 0. 2 minus 1 is +1. And the final overall charge here, again, all compounds are neutral. All elements are neutral. If it's not neutral, it's an ion, which means it has a charge. Right? So this is neutral. What is the name and formula of the compound combined? I will feed you at 5 pepper. All right, so calcium chloride is the name of, or is the chemical formula, CaCl2, and the formula name is calcium chloride. You should be familiar that if it ends in IDE, that means it's a second element. So hydrogen chloride, it's a second element. Hydrogen peroxide, the second element is oxygen, peroxide. Now, you should just be familiar with that. Sodium chloride, your salt is sodium and chlorine, and the last element is chlorine. So that's why it's sodium chloride. Right, so reset the selected data. So now fill this part out below. So let's reset the data. And valence electrons for sodium. All right, so you click on these. So sodium has 1 dot. You can look on the reference table too. So sodium's 281, potassium's 2881. But if you can't see that, just click on it. So yes, 1. Magnesium is in group 2. Everything in group 2 has 2 valence electrons. Everything, so including calcium, is 2 valence electrons. Aluminum is in group 13. Everything in group 13 has 3 valence electrons. And we should notice is that the metals, which are actually all the elements here, all the metals lose or transfer their electrons to nonmetals, right? So sodium is positive 1, positive 1. You don't have to believe me, the answers are right here on the reference table. Magnesium is positive 2. It says it right here. I don't know how these cats. And then calcium is always positive 2, wants to lose those 2 electrons. And aluminum is also positive 3. Metals lose electrons, right? And now we go to oxygen, all right? Oxygen is 2-6, so it has 6 valence electrons. Fluorine is 2-7, so it ends in 7, 7 valence electrons. Chlorine is 2-8-7, so again 7. Nitrogen 2-5, so it's 5. Sulfur is 286, so it's 6. And again, you don't have to use a I mean, for this case, you don't really need the reference table. The answers are over here. So chlorine 7. If you want to use this to double check your work, you do that. This would actually never bond. Right? And the charge of the ion. So ion, again, is when it gains or loses an electron. So oxygen is always -2. All right. Fluorine is always -1. Chlorine, the majority of the time, it's -1. That's why it's on top. Nitrogen, the majority of the time, is -3. And sulfur, the majority of the time, is -2. Right? And then you won't actually know the formula name, so I actually have to type this out, right? So if I know, actually, let me clear the screen, actually type these answers in. So oxygen is -2, -1, -1, -3, -2, right? So what you should also notice is the positive elements go first. That's a question I don't know why no one ever tells you that when you're doing this. So like my chemistry teacher told me like in like March, I'm like, hey, how do you know that hydrogen goes first or oxygen? It's like, I don't even think she told me. But I think she said the metal goes first, which is not always true. But the positive ion goes first. So it's sodium chloride, not chlorine sodide, right? So hopefully you caught that. The valence electrons for oxygen, if it's 2-6, we said sorry, right? 6, 7, 7, 5, and it should be 6. Right. So the formula, you have to balance them out. But let me write the names first. I'll feed you at 5. I'll feed you at 5. Sodium oxide. This is actually a lab where I gave you flashcards and you guys walk around and actually bond with other people, but it is what I need. Potassium fluoride. Cannot be this hungry. Fluoride. Magnesium chloride. So I'm hoping that you notice that the second element always ends in IDE. So it's not chlorine, it's chloride. Calcium nitride. You don't have to know this. The only thing you have to know is that the second element ends in IDE. Aluminum sulfide. Right. So the formula, I should try to teach you now. So the way it works, the easy way of doing it, if you don't know how to, if you don't know balancing it, is just switch the numbers. So if sodium is +1 and oxygen is -2, it's going to be 1 oxygen and 2 sodiums. Why is that? Because if I have 2 sodiums, it's +1 twice. If I have 1 oxygen, let me clear that. If I have 1 oxygen, it's -2. So +1, +1, -2. So this is Na2O. Sodium oxide is this chemical formula, right? Potassium, I have a +1, and fluorine, I have a -1. So I'm going to do any math there, unless you, never mind. So 1 plus -1 is 0. Magnesium is +2. Chlorine's -1. So who do I need more of? All right, I need 1 more chlorine to balance out the +2. So it's MgCl2. Calcium and nitrogen. So if calcium is +2 and nitrogen is -3, I switch the numbers. So calcium is now 3 and nitrogen is now 2. Does that actually work? Well, let's see. So if I have 3 calciums equals +6, and 2 nitrogens equals -6. That does balance out. So yes, the formula for this, let me clear the rest, should have that already, is Ca3N2. The next one is aluminum sulfide. So aluminum is +3, sulfur is -2. Switch the number. This is called the crisscross method. So it's now, don't transfer the positive negative sign, just transfer the whole number. So aluminum is now 2, sulfur is now 3. Does that make sense mathematically? Let's find out. So if I have 2 aluminums, if I have 2 of these, I'll have a +6 charge. If I have 3 sulfurs, I'll have a -6 charge. And yes, that does equal 0. And so it's Al2 S3. Aluminum sulfide is Al2 S3. How can you possibly pick this time to do this, right? And I think that's it for this session. There's another, this actually continues in part 2 about covalent bonding, but I just want to make sure everyone just understands the basics here about ionic and covalent, because we didn't spend that much time on it. Right? If you get stuck anywhere on here, just message me on Remind. But this shouldn't be that bad, right? Especially with this video. Right, have a good one.